Okay, so I may give you, and actually will give you on a test, a table like this. Um, and I'll say determine the missing properties. Fill in the blanks of this table. And what it really is, it's really 5 problems in one, right? Problem A, problem B, problem C, problem D, problem E. And in general, and we've talked about this, the state postulate, if you give me 2 pieces of information, then I can probably find everything else. And so that's what this is. Part A, it's telling us the pressure and the quality. We can fill out everything else. Part B is giving us the temperature and the internal energy. We can figure out everything else. All right, so let's fill out this table. So the first thing, determine the missing properties in the phase description of the following table for, all right, is it water or refrigerant? All right, it is water. And so also, let's see, Celsius, kPa, kilojoules per kilo. This is SI. So I'm going to be looking at Appendix 1, Table A4, A5, A6, A7, not 4E, 5E, 6E, 7E if it was English units, and not 11, 12, 13 if it was refrigerant. All right, so make sure you read this very carefully, because I'll definitely give refrigerant, I'll definitely give English units. All right, so now, problem number A. What if I tell you the water, right, is at a pressure of 200 kPa and a quality of 0.6? Well, that's easy. I mean, if you are told the quality, then you know this is a saturated liquid vapor mixture. And for saturated liquids or saturated vapors or saturated mixtures, I'm going to table A4 or 5. And actually, if you don't know what it is, you need to start at table A4 or A5. All right, A4 is the temperature, A5 is the pressure. So since I know the pressure, I'm going to go to table A5 and start there. All right, so since I know it is a mixture because of the quality, I know this is at Tsat. This is at Tsat. There's only one temperature for saturated values at a pressure of 200 kPa. Let's go to our property tables. Property tables. I'm going to go to table A, let's see, 4, 5, and 6. 4 was the temperature, right? This is organized by temperature. And so I'm going to go to table A5. And I am at a pressure of 200 kPa. Pressure of 200 kPa. So, all right, so kPa, yeah, 200. All right, so everything right here. Everything right here, that 200. Whoops. I would get a ruler, and put your ruler across here so make sure you're reading the correct line. But anyway, the temperature is 120.21. Whether it is saturated liquid, saturated vapor, or a mixture, saturated liquid and vapor, all of that is at 120. So Tsat is 120.21 degrees C, 120.21. Now, you don't have to write units up here because units are already written right there. And you have to fill it in right there, right? You have to fill it in. You can show me your work down here, but I'm really looking for that to be filled in. All right, now let me find the U. Let me find the U. And actually, all right, so this problem I'm asking for U, this could be H, this could be S, this could be V. So pay attention to what I'm asking for. I'm asking for U, internal energy, with a quality of 0.6. To find that U, I'm going to take the UF plus quality UFG. Right? I'm going to take the UF plus quality UFG. So go to the property tables for 200 for U. Make sure I'm looking at the right one. That's the UF. That's the UFG. So I'm going to take 504.5 plus 0.6 times 2024.6. 504.5 plus 0.6 times 2024.6. 1719.26. And make sure that makes sense. My UF was 504. My UG, I need to go back and look at that. It was in the next column. It's probably 2,500, 29.1, something like that. Make sure that your value is in between UF and UG. Make sure it makes sense. 1719.26. And that is problem A. All right. I think these tables are easier than the previous problem, than when you have a paragraph that you have to read and you have to decipher what it is telling you. Here it's just explicitly said, hey, here's the pressure, here's the quality, it's water, we're in SI units. All right, so that was A. Number B, part B. What if we've got a temperature of 125 and an internal energy of 1600? Is that saturated liquid, saturated vapor? Is it saturated liquid vapor mixture? Is it compressed liquid? Is it a superheated? I don't know. You don't know. And when you don't know, go to table A4 and 5. Go to the saturated quantities. And if it's on there, then it's saturated. If it's in between the UF and the UG, then it's saturated. But if it's out of the range, then it might be superheated or compressed liquid. All right, so let's go to table. Let's see which one, A4 or 5. 4 was the temperature one, so let's go to A4. Let's look at a temperature of 125 and see if that U lies in between the UF and the UG. All right, so property tables. And please, please, please do this with me. Do this with me. Don't just watch. Go get your property tables. Look up your property tables. Pause it. Try to get there before I do. All right, so I'm going to table A4. I'm going to a temperature of 125. And here, let's see, here are my U values. UF is 524. UG is 2534. My U was 1600. Yes, it's in between UF and UG, which means it is a mixture. Let me go ahead and write that in. This is a saturated liquid vapor mixture. You can just tell me saturated mixture, and I'll know. So, how about the pressure? There's just one pressure. There's just one pressure. It doesn't matter if it's, if its quality is 0.2, 0.7, if it was fully saturated liquid or fully saturated vapor, its pressure was Psat. If we went back to that, you can see I've got 232.23. 232.23. Now it's just finding the quality. So let's start at table A4. A4. It is in between UF and UG, so we're good. We know the pressure is at Psat. We know that it's a mixture. But the quality. Well, I know the U. I know the UF. I know the UFG. And so I can find the quality. You see how I don't write a different equation for U. I just write the same equation. Sorry, for quality. I just write the same equation. And, I'm going to subtract that over. I'm going to divide this through. All right, so look at your table. We've got our U is 1600. The U average of the whole mixture is 1600. The UF was 524.83 plus quality. Now remember, this is UFG, not UG. This is 2009.5. All right, so then subtract the 524 over, divide through by 2000. Right, it's an equation where you're solving for x. All right, an equation where you're solving for x. I've got an x of 0.535. 0.535. And does that make sense? Was 1600 53% of the way between 524 and I think the UG was 25, right? The UG would have been 25, 30 something. Yes. So, just make sure your answers are in the right range. Make sure they make a little bit of sense. All right. Problem number C. If they tell me, hey, we're still water, still SI units, the pressure is 1,000 kPa, the U is 2550. Do I know whether it's saturated or superheated or not? I don't know. So I'm going to start at the saturated, and if my values are out of the range, then I'm not saturated. I'll go to 5 because that's a saturated pressure table, organized by pressures, and I'm given pressure. So the A5 go to 1,000, and I'm looking for a U of 2950. Property tables, A5, it was 1,000 kPa. So here we are right here, 1,000 kPa. Let's see, my U values would be between 761 and 2582. My value was 2950. All right, it is too high, right? My U, my internal energy, is out of the range of this saturated table, and if it's too high, it is superheated, right? Remember, if your U is too high, it's superheated. If your H is too high, it's superheated. If your entropy is too high, it's superheated. If your specific volume is too high, it's superheated. If your temperature is too high, it's superheated. The only one that's a little counterintuitive is your pressure. You know, if you're at a temperature table, and if your pressure is lower than that, that is what makes it superheated. All right, so anyway, our U is too high. It is superheated. So we just jump over to the superheated table, which is table A6. Table A6 with a pressure of what? A pressure of 1,000 kPa, which is 0.1 MPa, and not 0.01. All right, which is this one right here. This one right here. And I've got a U value of 2950. Where's 2950 on here for the U? Where is 2950? Right here. A U value of 2950. Let me see. No. Sorry. I messed up completely. All right, did that to show you a big mistake. 1,000 kPa is not 0.1. Sorry, no. 1,000 kPa is not 0.1. It is 1. It is 1. All right, man. That would have been a big mistake. All right. So here we go. Let's try this again. There we go. 1,000 kPa, and y'all knew that. Y'all were yelling at me, right? 1,000 kPa is 1 MPa. And so my U value of 2950 would be between those two. Yeah, would be between those two. The temperature is going to be between 350 and 400. It's probably going to be a lot closer to 400 than it is to 350. We've got to interpolate. We've got to do some linear interpolation. Go back and look at the video on linear interpolation, or have your calculator do it. Let's go back and interpolate for 2950. If it's in between these two values, how far in between is it? How far in between 350 and 400? You can think about linear interpolation as similar triangles. You can go back to high school about if you have 2 points, you kind of know the slope, and if you want to know the point between the two, when you know the base, trying to find the height, or maybe you know the height, trying to find the base. I just always do top minus bottom over middle minus bottom equals top minus bottom over middle minus bottom, and just be sure that the things on the right and the left hand side of your equation are both in the right place. All right, so anyway, let's get back to our notes. Let's interpolate. So I started at table A5, but the U was too large, right? Too high. So I knew it is superheated. So I'm going to table A6, and I need to interpolate between 350 and 400, and between 2875.7 to 2957. All right, so I like to do, let's see, top minus bottom over middle minus bottom equals top 2957 minus bottom 2875.7 over middle minus bottom. And the middle would be 2950. Now, it probably makes a lot more sense to flip both sides of that equation. Flip both sides of that fraction. And you can do middle minus bottom over top minus bottom equals middle minus bottom over top minus bottom. I don't know. I just, the way I always learn it, I say that little ditty or whatever in my head. Top minus bottom over middle minus bottom. Top minus bottom over. So anyway, that's how I memorize it. That's how I do it. You can do it very differently if you're consistent. You know, if you make sure this one corresponds with that one. Make sure this one corresponds with that one, and that's the same thing. Make sure that one corresponds with that one. All right. Anyway, I've got a T of 395.2 degrees C. Does that make sense? Yes. I thought it was going to be closer to 400 than 350 because my 2950 was closer to the top number than the bottom number. So there we go. 395.2 degrees C. It was a super heated vapor. All right. Some books would have you say that the quality is 1. I don't like that. I reserve, when I tell you a quality of 1, I am talking about a saturated vapor. Similarly, when I tell you a quality of 0, I'm talking about a saturated liquid. For superheated vapors and for subcooled or compressed liquids, I like you to just write NA, right? Not applicable, as your quality. All right, because I like to designate, if I put a 1.0 there, I like for that to be for a saturated vapor, not a superheated vapor, okay? Okay, so that was part C. Now again, you can show me your work down here, but what I'm really looking for, you got to fill this in right here. Got to fill this in. All right, part D. Part D. All right, a temperature of 75, a pressure of 500. Do I know whether it's saturated or not? No. So I need to start at 4 or 5. Should I go to A4 or should I go to A5? Either one should tell you the same thing. All right, either one should tell you the same thing. If you have time, go to both of them. I think it makes more sense to go to the pressure table because that's the more logical. Temperature is more logical than pressure. I go to the pressure table. Let's go to a pressure of 500 kPa, and let's see what this temperature of 75 means. A pressure of 500 kPa from table A5. A5, a pressure of 500 would tell me a saturation temperature of 151. I'm at a temperature of 75. If my temperature is too cold for the saturation table, then it is a compressed liquid. So this tells me compressed liquid. So I'm going to go to table A7, the compressed liquid table. Let me just double check and see what would we have done if we went to table A4 and looked at a temperature of 75. It would tell me a PSAT of 38. My my pressure now is 500. But remember that pressure is a little counterintuitive. If you've got a really, really, really high pressure of 500, it is compressing this to a compressed liquid. All right, so if your pressure is too high, it is a compressed liquid. Either one, both of those pointed me to the compressed liquid table, table A7. Table A7. All right, so table A7, a pressure of 500 kPa, and y'all correct me if I'm wrong, because I did this wrong last time. A pressure of 500 kPa would mean I'm at a pressure of 0.5. I'm at a pressure of 0.5 MPa. I'm at a pressure of 0.5 MPa. That is not on this table. These are for pretty high pressures. I'm not on this table. So, first of all, just double check you're on the right table, because sometimes when your values are not on the table, it means you're not on the right table, but we're on the right table. Because I don't have values on the compressed liquid table, what do I need to do? I can estimate my U. I can say U is approximately equal to UF at the temperature. So I need to go and look at the UF at a temperature, not a pressure, of 75 degrees C. All right, so table A4, look at a temperature of 75 degrees C, UF is what? So table, go back. So we're just bouncing around here. Table A4, temperature of 75, look at a U value, 313.99. 313.99. And I don't want you to round. I don't really want you to assume it's a little bit lower. Just put 313.99. Okay. It is a compressed liquid. I like you to put NA and compressed liquid. All right, that was part D. Part E. Part E. This X value of 0, I want that to mean it is saturated liquid. It is saturated liquid. All right. Let's go to table A4 or 5, and I'm given the pressure. Pressure is A5. Let's go to table A5 for a pressure of 850 kPa, and let's just read the UF value. Let's just read the T-sat value. I think this is going to be an easy one. All right, table A5. Property tables. Table A5 for a pressure of 850 kPa. Well, the temperature is 172.94. I'm going to write that in, 172.94. And the U, 731.00. So there we go. No calculations necessary. 172.94. 731.00. All right. So that was 5 problems in one. All right. But it's real straight and to the point. It's real, straightforward. I think it's very clear what I'm asking you and what you're going to answer. There will be a problem like this on the test. It will have A, B, C, D, and E. It will be 5 problems. All right. So for a problem like this, double check if it's water or refrigerant. Look at the units, whether it's SI units or English units. Look at this right here. Am I asking for U for all of these, or H for all of these, or V for all of these, or S for all of these? Because I could ask any of these. And then, I hope that you can do this faster than I just did. I don't know how long this video is going to be, but you probably don't have time to spend, 25, 30 minutes on this problem. You need to be comfortable with your property tables and be able to do this quickly. Honestly, I'm not going to look at your work. All right, I'm not going to look at your work. You can do your work in your head. You can do your work, not have any work right here. I'm just going to put some check marks. There are 15 check marks. This problem is worth 15 points, or 30 points, is it? I need to go back up. Maybe it's worth 30 points. Yeah, this problem will be worth 30 points. 2 points for every box. Real easy for me to grade, and hopefully real easy for you to fill in all of those blanks. So practice these. There are some of these in the book that I think and hope, and I think you should really go to the book and practice. All right?